About how what you studied at Cambridge and a brief summary of what you then went on to do.
I studied biology at Cambridge, and I was interested in how plants and animals grow and develop. So I spent 10 years at Cambridge doing research on plants, how plants grow. And most people don't realize that there's a big problem at the heart of biology, how things take up their form. Because a plant or an animal starts from a fertilized egg, which hasn't got much shape. I mean, it's a round ball with things inside the cell, but nothing like as complex as you or me or an oak tree. And so the question is, how does all that complexity, how does that form appear? The usual theory is that it's just genetically programmed. That's what most people would just say, is genetically programmed. But it turns out the genetic program is a very vague concept that doesn't really explain anything. What the genes do is code for proteins, and they enable the organism to make the right proteins, the right chemicals. But how they're assembled, how they're put together, isn't understood.
Right.
And within biology, there's the idea that that's organized by something called a morphogenetic field, which means a field that shapes form. Morpho means form, genetic means coming into being.
Right.
And these fields are like invisible blueprints of developing organisms. It's like the architect's plan for a building, which is invisible. I mean, the plan can be written on a bit of paper, but the architect could just have it in his mind. The proteins are part of the chemicals the organism's made of, like the building materials. And you can't have a building just with building materials. You have to have a plan. So these fields are like plans. Now, they're part of a larger category of fields called morphic fields, concerned with form or shape. And morphic fields organize the activity of brains. They organize the behavior of flocks of birds or colonies of bees or termites or ants. They link together social groups. So there's a whole class of fields in nature, I'm suggesting.
Right.
And these fields have a shape which depends on a memory. That's where morphic resonance comes in. Right. Similar things influence subsequent similar things. So everything has an inbuilt collective memory.
Right.
Every species has its own memory. So if you train rats to learn a new trick in London, because of morphic resonance, rats all over the world will be able to learn the same thing quicker.
Right.
That's what I'm saying, that there's an
Quicker.
organizing principle in nature that enables things to happen quicker or easier after they've already happened. It's like a principle of habit in nature.
Okay. Now, that field itself then, I mean, from a physics point of view, electromagnetic waves are waves in the vacuum of space. So I'm of the mind, space is not nothing. It is a medium through which waves can push against.
Yes.
Now, is the morphic phenomenon that you're talking about, is it using space in the same way that electromagnetic waves push space as they travel as waves, or is it something else?
Well, it's in space. It's a field that gives spatial form or pattern. So it's a field that is to do with patterns and forms in space.
Right.
In that sense, it's in space. Now, the thing is that space is a tricky concept in modern physics. I mean, it's not just the ordinary three-dimensional space that we experience in daily life. Morphic fields are very like quantum fields, which are part of quantum theory. And quantum fields are in multi-dimensional spaces. I mean, physicists talk in terms of extra dimensions of space. And their mathematical models have lots of extra dimensions. The thing is, we can't conceive of these extra dimensions. So they come cheap in modern physics. They can just invoke them whenever they want. So the thing is, the known fields of physics, quantum fields, are in multi-dimensional space. Superstring theory says all fields are ultimately in a 10-dimensional space. So morphic fields, no doubt, are in spaces a bit like that, but it's none of them, even the ordinary fields of physics, are in straightforward three-dimensional space.
Okay, so it's in a dimension which isn't in our three dimensions, the morphic
Yes,
field.
I mean, exactly. That would really be if you model it mathematically.
All right.
But as the simpler way of thinking about them is the morphic fields in and around what it organizes, like a magnetic field's in and around a magnet.
Mm-hmm.
The magnetic field's inside the magnet, but it stretches out around the magnet as well.
Mm.
The Earth's gravitational field's in the Earth, but it stretches out round the Earth. That's
Right.
why it holds the Moon in orbit. Now, the morphic field of an oak tree is inside the oak tree and around it. Now, the bit that isn't, that's local in the sense it's in a place.
Mm-hmm.
But when the oak tree tunes into the memory of previous oak trees, the process of morphic resonance goes across space and across time.
Right.
Now, that may travel through extra dimensions, or it may go into some other kind of realm and then come back into this one. David Bohm, the physicist, called it an implicate order.
Mm-hmm.
So that you can model it in different ways. None of them are easy to understand, any more than regular modern physics is easy to understand. But the key point is the fields are within and around what they organize,
Mm-hmm.
and they have a memory from previous similar systems.
All right. Now, one of the statements that you use, which seemed to it sort of rang true with me, if you like, was that do minds reach out from brains, which is kind of what you're saying here, isn't it?
Yes.
And I've done a little bit of reading on where things are stored in the brain, and nobody seems to really have a clue how long-term memory works.
That's true.
And I think that I don't believe that long-term memory is stored in the physical grey matter of our neurons, in our neural networks.
Nor do I.
So that the brain is, for long-term memory at least, is an interfacing device.
Yes. Well, what I'm saying is that personally, I think brains are overrated. I think people assume that all the memories are stored inside the head, and they think that all our minds are confined to the inside of our head. And I don't think that's true. I think the brain's more like a tuning device, a bit more like a TV set or a mobile phone that tunes into influences coming from elsewhere. I think the memories, things that we resonate with, I think we have a collective memory. We tune into lots of other people in the past. But we tune into ourselves as well by the same kind of process, only we tune into ourselves more specifically because we're more similar to ourselves in the past than anyone else. That's why we get our own memories, not other people's. And so I think the brain's like a tuning system. The memories are not stored inside the brain. We resonate with ourselves in the past. When you go to a familiar place or meet a familiar person, when your nerve cells stimulate your eyes and senses stimulate the brain cells, they resonate with the same kinds of patterns when you saw that person before, and you remember it all by resonance. So the memory is not inside the brain, according to this theory.
All right. And does that describe what you would term the Akashic record, or is that another complete theory altogether? Because people say that.
Yes. Well, the Akashic record is an attempt to get at the same kind of idea. You see, in the 19th century, theosophists who were English people interested in Eastern philosophy, most of them were English, and they were out in India, they read up on Buddhist and Hindu philosophy. And in Buddhist and Hindu philosophy, there's the idea there's a kind of memory in nature. It's more or less what I'm saying. And they came up with the idea, the theosophists, of the Akashic records. Akash is the Indian word for space or ether. And so they had the idea that these records in space of what's happened in the past. I'm saying something very similar. There's a cosmic memory. The laws of nature are more like habits. But you see, the Akashic record uses a metaphor that I wouldn't use. It's record implies something like a filing cabinet or a CD or a tape recording or something. The word record, because we think of it in terms of books or filing systems, implies some physical store somewhere in space. Now, I don't think that's how it works. I think it works by resonance across time. And you can resonate, if you remember what you did yesterday, you resonate with yourself yesterday, but in between yesterday and today, it's not as if all that information has been stored in a static form
Yeah.
somewhere outside space and time in a cosmic filing cabinet or
Right.
something, or a cosmic hard drive.
Yeah.
It's a direct resonance across time.
Right.
So the idea of Akashic records is basically saying the same thing as a cosmic memory, but it's using a metaphor that I don't think is appropriate. I use a different one, resonance.
Right. And if I'd like to ask you about your work studying animals. For example, dog owners whose dog seems to think that they're coming home before they're anywhere near, and people who can wake their dog up by looking at their dog.
Yes.
I mean, the other thing that you also quote on your website is that experiments need to be blind or double blind.
Yes.
So for example, if you were going to try and prove that owners can wake up their dog by looking at it, how would you conduct a test in a blind or double blind situation with that?
Well, the thing is that blind or double blind, in this case what you use is a randomized trial. There's some tests you can do blind. That's when you don't know what. A blind test means, say you were doing an experiment and you were testing two compounds, A and B.
Yeah.
If they're enzymes in biochemistry, if somebody says, okay, if it's not blind, they say, well, this is the ordinary enzyme and this is the inhibited enzyme. And if you know what to expect, you tend to see what you want to see. This applies to regular science. That's why people use blind methods. Now, in some circumstances, you can't stare at a dog when it's asleep blind. I mean, you know you're staring at it,
Yeah.
so you can't possibly stare at it
Yeah.
when you don't know you're staring at it. So, the method you have to use there is a randomized method.
Yeah.
You see, if you stare at a dog and you can wake it up by staring at it, what the skeptics will say is, oh, well, how do you know it wouldn't have woken up anyway?
Yeah.
Or maybe you've made some noise that's made it wake up and
Yeah.
stuff. So what you have to do is have a series of randomized times. You could stare at it any one of 10 different times during a space of an hour. And then somebody else at random picks a number from 1 to 10 and says, okay, you're going to stare at it in period 7, not in periods 1, 2, 3, 4, 5, 8, 7. So if what happens is that you don't make any noise, ideally you'd look through a window. You'd have the dog behind a soundproof barrier.
Yeah.
Now, most homes don't have those, but you'd have to do it in the same room to start with, but you'd make no noise. You just, in that period, you stare at it. You videotape the dog all the time. If it wakes up during period 7, but not in other ones, then that would suggest something's happening. And if it could be a coincidence if you just do it once, but if you do it over and over again with different random timings, then you get the idea that the stare is actually waking the dog, rather than it just being a coincidence.
Because there are dog owners who will tell you this.
There certainly are. Yes, quite a lot of people say they can wake dogs or cats by staring at them. This is a rather good research project. You see, the slogan for it is "Don't let sleeping dogs lie." Right. Stare at them. So the reason I'm doing this research is because I'm interested in the way the mind extends beyond the brain.
Yeah.
And this is something that happens to humans. If you stare at a human being from behind, if you stare at another person, they don't know you're there, they can often feel it and they turn round. And that's what I call the sense of being stared at.
Yeah. And you think that in animals' evolutionary process where they're preyed on, other animals are trying to kill them, then it would be useful to know if you're being stared at by a predator.
Absolutely,
and that's possibly where that phenomenon is developed, perhaps.
Yes, I think that's where it's come from, because, you see, I think our minds stretch out beyond our brains. So, if I'm looking at something, say I'm looking at a dog, I don't think there's a sort of little cartoon-like dog inside my head. I think my image of the dog is projected out through my eyes to where the dog is. I have a kind of dog image in my mind, but that's projected to where it is. So my mind touches what I'm looking at. Right. And that's why dogs or people can feel when they're being looked at. And I think all animals have vision that works like that. And I think in the course of evolution, if prey animals were able to become sensitive to when predators were looking at them, they'd escape better. So I think it's something pretty basic in animal nature, and the reason humans have it, and more than 90% of people have said they've had this experience, it's very common. The reason we have it is simply it's part of our animal nature.
Right.
And it's useful, and people who are in dangerous situations, people in the army and stuff, pay attention to this, and so do detectives and surveillance officers. They're trained to know that if you're watching somebody, if you're following somebody as a private detective, you don't stare at their back while you're following them, because they're likely to feel you, turn around and catch your eye, and your cover's blown. You look at them a little bit, otherwise you lose them, but it's better to look at their feet.
Right.
And in the martial arts, people are trained how to become more sensitive to being stared at from behind.
Why not join me, Richard D. Hall, live for an evening on board the Starship at the Oaken Gates Theatre in Telford, 11th of May 2011. In the show, I'll be addressing many of the areas I've covered over the past year, including false flag terrorism, UFOs, animal mutilation, the financial crisis, and more. Learn what your government isn't telling you and what your media isn't allowed to tell you. Tickets are available now from the Oaken Gates Theatre website. Further future venues include Weston-super-Mare, Leeds, Barnsley and Newcastle upon Tyne, with further venues to be arranged. Find more details on the richplanet.net website. Now, there's a particular parrot I would like to ask you about. So you did quite a bit of research with this parrot that had, I mean, tell me about it.
Well, a lot of animals can pick up their owner's intentions, and I described this in my book, Dogs That Know When Their Owners Are Coming Home. And some of the most sensitive animals turn out to be African grey parrots.
Right.
And I've been working with one in the United States that's not only sensitive to its owner's thoughts and intentions, but because it's got a big vocabulary, it can actually speak.
Yeah.
And so it actually says what she's thinking.
Really?
It sleeps in her bedroom, and it sometimes wakes her up from her dreams by commenting loudly on her dreams.
Really?